And when I think of myself as like even a 6-year-old future engineer with like a 3D printer at my disposal, oh my God, I would be so, I would just lose it.
Thanks for sitting down with me today. Appreciate it.
No problem.
It's great to sort of see the facility and meet some of the people here that I've, like I said, talked to over the phone or email. What was your background and how you got into 3D printing?
Yeah, so my background is actually, I'm a mechanical engineer with a biomedical master's degree, and I did medical devices for like 10 years. Through university, I got 3D printing like under my belt. We had a lab at my university that made me realize that there's actually a lot of like design for manufacturing that needs to be considered when you do 3D printing.
Right.
Because if you try to take an injection molded part or a CNC milled part and just spit it into a 3D printer, it will fail for all sorts of new reasons.
Right, yeah.
But if you have this sort of hat on where you're thinking about designing for that manufacturing method, which as an engineer, engineers are trained to think of not only what does this part do, but how are you going to make it? So that kind of experience had me started thinking that alley. And I was doing early medical device development, which uses a lot of 3D printers, obviously. Started doing that, and then actually was surprised by the rep movement. I had a buddy that actually got a 3D printer, like the first 3D printer that was like under $1,000 and was a kit, built themselves. I was like, how did you afford a $100,000 3D printer, friend?
Yeah.
And turns out it was, an early one of those kits, and it was really cool to be able to put together. And that sort of turned into, as an engineer and Taylor, who had the 3D printer, we started in the evenings and on the weekends doing designing and print services. And actually that was about the same time that MatterHackers was starting to do software and filament. So we literally, our little business shared a wall next to each other. After just a couple months even, just decided all right, well, we're both doing 3D printing. Let's mash these things together and see if we can go at it together. So that's kind of how I got involved with early 3D printing for a while, and how I got involved in MatterHackers here. And yeah, it's been a heck of a ride.
What are the trends you see now, and where do you think things are going in the next 5 years?
When we think of where the industry is going, obviously there's a huge sector which is kind of, when you think of the hobbyists or these early adopters that are really doing a lot of the groundwork. That's where the rep movement started. And such a cool community. That's the roots of all these 3D printing that's going on. There's a lot of development that's happening there. So that is forever a piece of the 3D printing ecosystem where I think things trickle up.
Community-based development.
And if you look back 3 years ago, education really took on to 3D printing, and MatterHackers was able to help a lot of education systems and schools really bring on 3D printing. So kind of hobbyists, education, and then, even from where I had my experiences at a Fortune 500 pharmaceutical medical device company, they've always been doing 3D printing, but they're starting to adopt the desktop 3D printers and starting to have conversations with SpaceX, Tesla, pharmaceutical companies, automotive companies. All these companies are starting to, instead of buy one, $1 million machine, instead take those funds and spread them out and get kind of a printer on everybody's desk is, I think, the next step that we'll start to see, so that productivity can really flourish. When you think about someone who's on a short timeline, needs to do a lot of iterations on a product, and doesn't want to wait in line or wait for an outsourced service to get their parts back, but instead, if I got a 3D printer next to me, I could essentially, of a small part, do 3 or 4 iterations in a workday. And that is something that's powerful. When you think of the inverse of that is waiting 2 weeks for your first prototype to come back. So companies that have timeline-driven decisions, I think when you have those types of conversations about productivity, that is where I think that the next year or two, 3D printing will really start to grow in terms of where it'll get adopted.
Things look so different in a CAD model versus even if you like, I model with a ruler and a set of calipers next to me, you know, and even doing that, once you have the physical object in your hands, you're like, this doesn't look right, or this doesn't feel right, you know, it doesn't fit right. Being able to rapidly reintroduce iteration is
the
great.
motto that I live by is fail early, fail often, right? So that's that's something that I've adopted of like, all right, you got the CAD model, let's spit something out so you touch it, feel it, and figure out where you can improve it for the next iteration. So beyond that, I think those are kind of like the sectors of the 3D printing industry that we think of. But I think the thing that'll drive across the board for all three of those will be materials. So the materials will be what people are talking about. And obviously PLA is the king of all materials in terms of like volume and how many people use it. It's just so easy. It's like a magical material, honestly.
It's
to consider.
affordable.
Affordable, how easy it is to use, how easy it is to print. It's mechanically pretty sound as long as you're not in a higher temperature environment, to be totally honest. It can be a little bit brittle, but those are kind of corner cases, to be honest. Most of the volume in the industry remains PLA, and that's a really strong foothold that it has, and it'll be tough to, I can't imagine much overcoming that in terms of volume. But when you think about like more functional materials, even PETGs, still really easy to print with, but has a little bit better mechanical properties. Then you kind of climb up the ladder to nylons. Like, oh my gosh, nylons, if you fill them with a little bit of carbon fiber or some glass, you get really rigid parts that can be used for even more functional aspects. And then between nylons and, you know, some of the even higher temperature materials, PEIs, PEEKs, Ultems, things like that, I think is where a lot of the growth will come in terms of the industry, and a lot of material science companies that are going to be leading that to be able to say, hey, you didn't think 3D printing was for you? Well, check out this material that can be put into your automotive application or build a drone or, you know, whatever the case might be. I think there'll be more conversations and more realizations that desktop 3D printing isn't for jokester little 3D fills, but instead things that can be functional and really put to those tests in conjunction with those high temp materials that are really considered metal replacement. Ultem's a metal replacement. PEEK is a metal replacement aerospace grade material that can be printed on a desktop material thanks to these, you know, accessories that can reach those temperatures to, you know, make those thermoplastics into melty goop again. So that's a really where I think the capabilities will start to talk about. And then even if you talk about like kind of the BASF Ultrafuse, the stainless steel, you know, debound and sintered materials that you come back with actual metal parts, right? So I think the material science is going to be what pushes and really opens the doors for a lot of people who previously didn't think that their workshop needed a 3D printer.
I know something we were really excited about was when the Air Force cleared Ultem for Air Force applications, and so did the Navy. We were like, oh my gosh, this is huge. You know, that now our armed forces are going to be using this plastic as a metal replacement, especially for things that are getting phased out. I remember reading a report about how it was costing the Marines some ungodly amount of number, $100,000 or something, to replace a door handle on a Humvee that was going out of production, right? And then they sent the Marines a 3D printer and they printed it for $5.
Absolutely.
So $100,000, $5 is like not even really a comparison.
The money aside, I've heard some case studies in both the Navy and the Coast Guard actually, where they're like, how do you get that part when you're in the middle of the ocean? And it's amazing to hear like these stories of if a little plastic piece in the dishwasher on a Coast Guard cutter goes down, that means nobody can eat. So like, sort of it's amazing how like, you 3D print this little useless piece of dishwasher, and you're like, oh, well, that's not the engine part of the boat that's making it go, but these are critical components that like, if you go down that failure mode and effects analysis, you're like, yes, dishwasher can shut down a whole ship and make it pull over into the closest piece of land to go get that, 3 weeks to get that replacement part or whatever it might be. So to be able to solve those types of problems aren't money. They're not, again, you kind of go back to that productivity and those kinds of timelines that don't talk about money or anything like that. It's just like, hey, how can we get this up and running so quickly?
Yeah, logistics are huge, right? Especially in a large organization where you're moving quickly. Like just even that dishwasher piece. That's such a great example of something super tiny that brings a massive organization to a halt, right?
Yeah.
Because you don't have.
And then someone says, "How do we get that up and running?" I don't care what it costs.
Do it now.
How to get it. Yeah.
Do it yesterday.
Yes. Yeah. So that type of productivity. How do we open more of those doors? We talk about the applications, the materials, and the hardware that will have you succeed in those cases.
So how have you guys seen, for some of your customers, use Slice products or the Mosquito specifically to improve the outputs that they're getting or improve their capabilities?
Yeah, so I think when I first saw the Mosquito, I was just sort of blown away by its simplicity. Your background and your founder's background there, you kind of see like, oh, they took these, sort of applications of off-the-shelf components that are, in other applications kind of hard to machine parts and keep that small melt area to be able to do that. And I was like, oh my gosh, this could kind of change the game of the way people are doing that application. And the fact that you can come to market with higher temperatures, more capabilities, more compact applications. And I think that's where we've seen the value of the Mosquito and even the Magnum Mosquito, to be able to say like, hey, you can do everything you need to do in a more compact space. So if you're gonna upgrade your machine, don't sacrifice any Z height or an instance like that, and really expand the capabilities of the print temperatures that you can go up to, and some of the technology that you guys are bringing to simplify the rigidity, the melt flow, the retractions not being egregious, things like that are all great applications that we've seen customers really succeed with.
Very cool. Any sort of parting thoughts for?
No, I think for the community in general, I think we're just excited to see everything expand, new doors open, new materials come to light, and we really are out there. We're hitting the pavement and trying to figure out where this ship's going and how we can help be part of that and be really efficient, be competitive in all of the pricing, and really, help the industry get to where it's going. Like we're passionate makers here, so we want to make sure that everybody can join the party that we're on. And I think when it comes to Slice and the things you guys are doing, more people dedicated to the optimization and the efficiencies of those more materials and those new case studies being open are going to point 3D printing in the right direction for the future to be really bright for engineers, hobbyists, educators, kids, like everybody, to really expand the capabilities of when they think, hey, I have this problem, how do I succeed with it? And like whether you're going to use a table saw or a chisel or a 3D printer or a CNC machine, like another tool. And I just love that the industry is expanding and people are doing some of the coolest stuff right now with 3D printing that has ever been done because of how many are out there and how capable that it all is.